Hi guys, welcome back to my channel Pirai Academy. In the series of Soliton interview question, today we are going to see about a funny question as well as a interesting and little much hard question. Okay, it is flames. So by seeing this name itself, you will be knowing what is exactly meant by flames, and it is also called as relationship calculator in the technical terms. But we know that in our younger age we must or we have just used this flames. Okay, fine. So what does this flame stands for? So it is friends, love, affection, marriage, and enemies and siblings. Okay, so this is what it means. Fine. So let me go with an example so that you can understand it clearly. So here is my friend's name, and you can see here, and you know what this name means. Fine. Okay. Now, if I take these two names, then it is for love. In the relationship calculator, it is showing me love. But how we are going to do this? Fine. So the logic or algorithm behind this is, first of all, we want to just strike out what are all the same letters or characters that are there in both of these names. For example, here in Darshan, it is here this R and this R strike out. So it is case insensitive. Okay. Now whether this S is present here, whether this D is present here, no. Whether A is present here, yes, strike out it. Whether S is present, no. Whether another A is present, no. Whether N is present, no. So what are all the remaining characters I have? So it is 1 2 3 4 5 6 7 8 9 and 10. So totally 10 characters are remaining, right? Now just write F L A M E S. Okay. Now you want to start from here at the first character. Okay, so let me take any other color. Okay, now I am just starting from this first character and just go with 1 2 3 4 up to 10. Okay, so this is going to be my 1, then this is 2, then 3 4 5 6, again come here. Okay, 7 8 9 10. So this is going to be straight out. Fine. Now next iteration, in your next iteration or in your next thing, you want to go with this E. You want to start with this E. Okay, now 1, so here is 1, then 2, then again come here, so it is 3 4 5 6. Sorry, you don't want to take this, strike out letters. Okay, again, so 6 will be going to be here. Hope you understand this. Now 7 8 9 10. So this is strike out. Okay, in next iteration, you should not take this M. You want to start from this E only, because this M is strike out, which means it is taken off. Okay, now 1 2 3 4, again come here, 5 6 7 8 9 10. So siblings is strike out. Okay, now again you want to start from here, 1 2 3 4 5 6 7 8 9 10. So friend is strike out. Okay, now let me take the screen blur. So you want to start from here, so 1 2 3 4 5 6 7 8 9 10. So this enemy is straight out. So that's how here this L is left over. So what is L? It is love. Hope you understand this. And this relationship calculator for these two names is real. Okay, fine. Anyhow, so what is the basic logic behind this? So there are few logics behind this. So first of all, we want to take care of what are all those leftover characters count, right? Apart from those matched count. So we want to find unmatched character count. Hope you understand this meaning. Okay, and basically it is in case insensitive. Okay, which means lowercase and uppercase are both equal. Okay, uppercase A and lowercase a are same. Hope you understand this. Okay, so this is going to be your first step. You want to just take the count of the unmatched pair. Okay, what is your second step? You want to just go along this logic and find what is the rest over element. So basically you want to do 5 iteration, okay, to get rid of 5 characters, while the last one characters will be there and that one character will be your answer. So 5 iteration over, what is the logic? You want to pick from one element or one character, and you want to go and count along with what? Along with the count of the unmatched pair. And when that unmatched pair count is exhausted, okay, then you want to take the current character and make that current character to be removed. Okay, that's going to be your algo. So do this algo for 5 iteration. Then you will be left over with one character or some indices, like then you want to just print what is the relationship between them. So finally you want to print the output. That's it. So this is going to be your entire logic. So by seeing this, you can understand what is the entire solving of this problem. Fine. So let us go with the algorithm. Fine. So now, first of all, you want to find what are all the unmatched character count, right? Okay. To find this in an efficient way, okay, we want to just go with maybe a hash map approach. To count it efficiently, you can go with the hash map approach. But unfortunately, in your Soliton interviews, always you are preferred to use only the C programming or C language. So in this case, you want to go with the frequency array. Okay, and I want to tell you the brute force approach in the overall way. Okay, what is the brute force approach? Okay, the brute force approach is you want to just go with the particular name first and the next name. Like the brute force going to be like, I want to take the Darshan and I will be taking this D. I will be taking this D and checking whether this D is present in this another name. If it is present, I want to remove the D in the another name. And I will be going for this A. Can you understand this? If this R is present, then I will be removing the R from the another name. This Kritika, this name. Okay. And then I'll be just skipping to the next character, this S. Hope you understand this. So this is going to be your brute force approach, and it will be taking a maximum of over n into m. Okay. So this can be your time complexity in the worst case. But we want to do in a best case, or we want to do in an optimized approach, right? To do this in an optimized approach, we want to go with the frequency array. Okay, I'll be telling you clearly what is my frequency array, as it is much important while you are solving any questions that are based on the counting of each characters in a string. Then you will be always going with the frequency array. If you already saw my basic playlist and you already know this approach, just skip away and go to the next part in my video for this 5 iteration for this algo. What is the algo? Okay, fine. So don't worry, you can also just resolve it, because it will be more important when you are solving anything in the C, for especially for the string counting techniques. Okay, fine. So let me take Darshan. In a say this is Darshan. Okay, now I will be iterating over this. Okay, so here is D, right? So I want to take the count of each and every characters. To take the count of each characters, just tell me how many alphabets are present in my English letters. So there are totally 26. Okay. May the name have any numbers or any special characters? You can say no, but the name can have a space. Okay, whenever a name has space, that won't be affected in the flames algorithm. Can you understand this? Yes, the space will not be taken as an individual character in the flames algorithm. As you know, in your childhood, you have I am pretty sure you have tried that flames algorithm. Okay, fine. So here comes we want to take 26 size of integer array assigned with 0. Okay, so here is a 26 size integer array assigned with 0, and this 0 represent the A, and this 1 represent B, and this 2 represent C, and then up to this Z represent 25. Hope you understand this. I will be telling you how we are going to convert this. Okay, and inside this 0 represent each character's count is initially 0. Okay, now I am going to just take this D. Okay, now I am just going to take this D. Now, what is the ASCII value of small d? Or as a way we are just told you that it is case insensitive. Case insensitive. If for example, if there is any uppercase letters, then I will be just adding 32 to them to their ASCII values to convert it into the lowercase letter. Okay. So anyhow, we are just going to calculate in the lowercase letters. Okay, so lowercase letters will be starting from 97 up to 122, while uppercase letters are starting from 65 to 90. Just remember this ASCII values. Okay, now I'm just checking whether this D is alphabet. Yes, it is alphabet because it is in the range of 97 to 122, or else it is in the range of 65 to 90. I'm just checking whether the D is in the range of these two. Yes, it is in the range of 2, but another time I am going to check whether this D is particularly the lowercase or uppercase. If it is uppercase, then I want to just make sure to convert it into the lowercase. Hope you understand this. Okay. Now, what is the ASCII value of D? So the ASCII value of D is 100. The ASCII value of D is 100. Okay. Now I am going to subtract 97 from this 100. Why? Because 97 is the ASCII value of A. If I subtract that from A, then it will be from the zero based indexing. Can you understand this? If that is A, then 97 minus 97 is equal to 0. Then I can go with this index. Can you understand this? Okay. Now here comes what? 3. So I am just going to the third index. So here is the third index and I will be changing this to 1. Can you understand this? Yes. Similarly for this A, again A is 97 minus 97, so this is equal to 0. 0. So here I go and change this to 1. Again R. For this R, it will be something like here, right? When you are minusing with 97. So here I will be changing to 1. Again it is S. So where is S? Where is S? Here. So I will be changing here to 1. Now again A. So again here I go and change this to 2 now. Okay. Now N. So where is N? So N is here. So I will be changing this to 1. Now I will be going with the another name. Okay, what is the another name? This Ritika. Okay. Now here, first of all, this is R. This R is alphabet, but it is uppercase. But it is uppercase. So in this case, I want to just add R plus 32. Then it will be converted to lowercase a. Can you understand this? Sorry, lowercase r. Can you understand this? Yes. Okay. Now I will be going to this r and I will be subtracting. So here it is like I will be subtracting 1 here. So if I subtract 1 here, it will be something like 0. It will be something like 0. Okay. Now here comes e. Where is e? Here. So here if I subtract it, it will be what? -1. But whether any count can be of -1? No, right? In this case, you will be just taking the positive value. You will be subtracting. You will be subtracting from the number in that current index, and if the resultant is less than 0, which means the resultant is negative, then you want to convert into a positive number. That's it. Now what is the next character? It is e. It is e. Now here it is 0, so I will be making this as -1. Simple. Now again it is e. Again do -1, so it is -2. Now t. So go to t and make this as -1. Now h. Go to h and make this as -1. And then I. Where is I? Here. Go to this and take this as -1. And k. Where is k? Here. Take this and make this as -1. Now a. A is already 2, so -1 will be resulting in 1. Can you understand this? Now you are going to take each and every index count, okay, and making them to a sum of value to find what are all the unmatched characters count. Fine. So I will be traversing from this a. Okay, what is the a's value? It is 1. So 1 plus. Again, here it is 0. So plus 0. Here also 0. So in algorithm, it will be taking each and every character's count. Okay, whether it is 0 or anything. Fine. Now here d is 1. So plus 1. Plus here e is what? -2. E is what? -2. So basically whenever we are encountering anything like minus, then we will be making them into plus, right? So -2 will be converted into +2 because that also will be in my count, right? Which means so it is like this e it is 2 times more than the first string, then sorry, more than in the second string than the first string. Can I understand this? In this Darshan, e is 2 times less than in the Ritika string. Can I understand this? So +2. Now plus here all 0. I'm not going to take this 0 heads up. No, in your algorithm it will be taking. Okay. Now here it is -1 into +1. Now again +1. Again 1 here, 1 here. Then 0 for this R. Then 1 for this S. Then 1 for this T. Okay. Now if I add these things, it will be 1 plus 1. So 2, 3, 4, 5, 6, 7, 8, 9, 10. We got the answer. So this is the procedure. This is a procedure to find the unmatched character count. Okay. Now let us jump to the next thing. So what is the next thing? It is we want to do a 5 iteration over algorithm, so that we will be ending up with the only one character that will be the resultant of the relationship calculator. Okay, fine. So let me take this. Fine. Okay, so this is going to be your 0, 1, 2, 3, 4, and 5. Fine. Now I want to just going on and traversing over this characters. I'm going to eliminate each and everything, right? So it is difficult to remove in the string or array anything. So that's why I will be taking the visitor. That's why I'm taking the visitor. I'll be telling you that while I am traversing. Okay, hats off now. Just see here. So what is the number we got for the unmatched character count? It is 10, right? Okay, take this 10. Now initially the count will be 0, and initially my index is 0, which means I am starting from here. Okay, fine. Now I am starting from here. Now whether my count is less than my 10, yes, then you can proceed. Hope you understand this. Okay, if I proceed, first of all I am going to check whether this f is strikeout out already. No, it is not strikeout out, right? So go on further proceed. So I'll be going to this L and making this count as 1. Now I'm just going to check whether this 1 and 10 is equal. No, then I will be making my index +1, which means I am currently now here. Okay, now I am just checking whether this 1 is less than 10 again. Yes, so I'll be making this 2, then it will be coming here, and it will be also 2, and then again this will be 3, again this will be 3, and it will be coming here, and 4 here, and 5 here, also 5, then 6. When I'm going for the count as 6, okay, when I'm going to the count as 6 and index as 6, at this point my count will be not changed, because the count is a variable that is going to check whether my current iteration is less than the unmatched character count. Okay, but this index represent the whether it is f or L or A or M or E or S. Can you understand this? Yes. So in this case my index cannot be of 6, because there is no more in the 6 or greater than 5. Okay, in this point I will be doing a modulo operation with 6, so that I will be getting what? 0. Can you understand this? Once you are completing this, and then again you want to go with the circular type, you want to go here. That's the rule. Yes, so I will be going there. So again here comes 0. When count is 6, we will be going to 0. Okay, so again this count will be 7. Here comes 7 mod 6. I understand this. If this is not 6, if it is 7, then also it will be 7 mod 6 will be 1. As of now it is 0. So 0 plus 1, it is 1. Anyhow, I am just telling you how this mod operation works. Again, you will be at this 1. Okay, now again this will be 8. Now you will be here, it will be 2, and you'll be here. Let me go with the down arrow. Okay, now it will be 9, here it will be 3, and you will be here. Now let us go and see what that algorithm means. Okay, so initially I will be taking 0, 1, 2, 3, 4, 5. So these all going to be your flames indices. Okay, if this is a string, then it will be the indices. Okay, so this is not important. This is for the imaginary part. So this is going to be your imaginary. Okay, not in a real time application. Like in heap, it is like a imaginary tree, but it is as usual the array. Like that, it is also imaginary. Okay, fine. Now initially I will be taking the count. What is mean by this count variable? This count variable will be just making sure that my current iteration is less than the n value, this n value. Okay, and this index represent what is my current character, like whether it is f or l or a or m or e or s, like that. Hope you understand this. Now just listen this. Initially my index is at 0. Now whether my count 0 is less than my n value. Yes, it is less than. So what should I do? I will be just go on iterating it. So initially I am here. Now I will be iterating to count plus 1 because I want to check whether this f is strike out already. No, it is not strike out already, right? So my count will be become 1. Now I am going to check whether this 1 and this 10 both are same. No, it is not same. Then you can go on further continue. You can understand this? What I am going to do first, I am just checking whether my n value is greater than the count value. Always. If it is okay, then I want to go and iterate. What should I iterate? First of all, I want to just check whether it is already cancelled. Okay, if cancelled, then I will be just making my index to plus 1. Okay, if not cancelled, then I want to just go to what? I want to check whether it is not cancelled. Okay, you can see here this f is not cancelled, right? If it is not cancelled, then I will be making my counter to plus 1. And then I want to check whether the count is equal to my n value. If it is so, I will be breaking here itself. Else only I want to go to the index plus 1. Okay, now I am going to the index plus 1 and let me take any other color. Right, now here comes what? 1. Here comes 1. Now I am currently here. Can you understand this? Yes. Now again this count will be 2 and then here also 2. So it will be here and this also 3. So here. Up to this it will be 5 and 5. Okay. Now when I am going to the next iteration, this count will be 6. 6 is less than this 10. But the index is what? Index is still 5. And then if I take this as 6, whether there is anything in this 6th index? No. So you want to now go here to here, right? That's the procedure for the flames, right? So how I can go here to here? Just to do a mod operation with the length. What is the length? It is 6. So which is equal to 0. Can you understand this? So as I mentioned in the basic playlist itself, if you want to just go to the first, go to in a manner of circular array, then you want to do a mod operation with the length of that corresponding array. Fine. Okay. Now again I will be going here, and now I'm just standing in this here. Okay. Now it will be 7, and whether the 7 is less than this 10. Yes, absolutely, and it is not equal to 10 also. Now I will be going to this 1. Now again this 8, and then this is 2. Okay, so I am currently at this point. Now listen this carefully. This is going to be your more important step. Now I am just going to change this to 9. And then this index is 3. So I am here. Now whether this 9 is less than this 10. Yes. Okay, leave it. Make this count as 10 because current index. This is not striked out. Okay, so I'll be just making the count as 10 as of now. Whether this 10 is equal to this 10, yes, so I'll be breaking out. I'll be breaking out and terminating the current iteration. Now I'm going to strike this m outside. Okay, so it is basically like I want to remove the m. So instead of this remove operation, I can simply say you that we will be taking a array. Okay, array of size 6, and initially that array will be containing everything as 0, so it is an integer array. Okay, now whenever I am striking out some elements, I will be making this 0 into 1 at the particular index. Hope you understand this. So whenever this visitor array, basically we will be telling always this is a visitor array. Okay, whenever the visitor array of the particular index is 1, then I want to skip that particular character or particular index because it is already taken. Hope you understand this. Okay, now my index is what? 3. My index is of 3. Now I'm just making the current index value as 1 here, and I will be moving on to the next non-cancelled character. So I will be checking whether this 4 is non-cancelled. Yes, so I will be going and standing here for the next iteration. Okay, for the next iteration I will be just checking this, then checking this, then checking this, then checking this. When I am going to this third index, I will be checking in the visitor array for the each and every iteration, and it is what? It is 1. So I will be just not taking this and go to the next thing. Can I understand this? So I will be repeating this step for 5 iteration, and the remaining 1 letter will be the resultant. Hope you understand this approach. Yes. Now I want to tell you, for this approach we can do in an efficient way also. Like we can do this like it is 10, right? Do a mod operation with 6. It is an additional or bonus approach. Okay, mod operation with 6. So which will be what? Which will be of 4. Now take the flames. Do the same steps. So 1, 2, 3, 4, strike out. M is strike out, right? Then 1, 2, 3, 4. L is strike out. 1, 2, 3, 4. F is strike out. Now tell me, what is the time complexity? So time complexity will be O of how many unmatched character count. So it is going to be your time complexity. Okay, so it is basically of 5n. So approximately it is equal to O of n only. And then what is my space complexity? So it will be of O of 1, because we are taking a constant space of 6, right? And then here it is basically of when in the worst case the time complexity will be almost equal to the sum of 2 characters. So it will be O of n plus m. So this is going to be your time and space complexity analysis. Okay, so let us see the code, and we can just go with how we can further optimize this technique. Okay, like see here this algo is somewhat weak, right? This algo is somewhat weak, so we want to just further optimize this algo. Can you understand this? So how we can optimize this algo? So this is going to be your bonus approach. So this is very much important. Okay, how to optimize this. Fine. So it is not like much optimization, but still it is going to be your very important problem called Josephus problem. I don't know whether this is a correct spelling or not, but it is a Josephus problem. Okay, I'll be telling you this, but before we can just go and just watch that coding part, and we can come back to this Josephus algorithm. So this is going to be a code. Always prefer a C code for this Soliton Technologies interviews. Okay, fine. So here, so you want to convert every uppercase into the lowercase, right? So as usual, I have told you, just we want to check whether it is a uppercase letter. Then we want to return the current character plus 32 as the ASCII value, and we want to return that CH. That's it. Okay. Now we want to check for the alphabets, right? And also in your Soliton Technologies, you are not allowed to use inbuilt functions, but you can also use the inbuilt functions like strlen, but still Still, apart from that, you cannot use any other inbuilt function. So that's the reason why I am telling this two functions. Okay, fine. Now return ch is greater than or equal to a, like it is like we want to just check whether the current character is whether uppercase or it is a lowercase by checking whether it is in the range or that range. Then I will be returning true. That's it. As I told you in the drawing explanation itself. Okay, fine. Now how we can going to calculate the unmatched character count. So here is the frequency array approach. Okay, first of all, I will be taking a 26 integer array size, and so we will be initializing that initially as 0. Okay, now int I. Now I will be just going on and traversing in the name one, and I will be checking. Sorry, I will be converting each and every character into a lowercase character. Okay, and then I want to check whether it's an alphabet, because in our name there may be of any spaces, so we don't want to take that spaces in our frequency array. So that's the reason why I'm just checking whether it is an alphabet or not. If it is an alphabet, then I want to just go and add that count in my frequency array. Okay, and then now I'm going to traverse in the name 2, and then now here there is only changes. We want to do a minus operation in the frequency array, as I told you in the drawing explanation itself. Now my unmatched will be 0 initially, and I am going to traverse in the frequency array, and I want to check whether the frequency array element is negative. Then I want to make that into a positive, and then I will be taking the frequency array current in this value, the count, to the unmatched. Okay, and I will be returning the unmatched. So this is going to be a function called calculate unmatched. Okay, now here comes the logic for the flames. So how we are going to take the visited array of size 6. Initially everything is non-visited, so it is 0. Now remaining will be 6. Now index will be 0. Can I understand this? Okay, now int eliminated is equal to 0, eliminated is less than 5, eliminated plus plus. So we are going to do a 5 iteration, so that we will be eliminating each and every characters or each and every letters in one iteration. Okay, fine. Now count will be 0 initially. So why I am taking this remaining? Okay, fine. So remaining is not coming here, because I think so I just taken it, I don't know. Okay, fine. Now int count is equal to 0 and count is less than n. Then what should I do? I should be just checking whether it is a not strikeout. It is not strikeout in our previous iteration. Then only I want to do a count plus plus. Then I want to check whether the count is equal to the n. Then I want to break it. Else I want to go and further proceed with index plus 1 mod 6. Okay. Now after finishing this entire loop, then I want to just make sure to visit, to mark it as a striked character in a visited array for the current index. Now I want to do a do while loop. How? I want to just make sure my next index is not striked out or not cancelled character or index. Okay, so the next thing is I'm just going on and iterating over the visited array, and I'm checking what is the index that is in the visited array as 0. Then I will be returning that index. Okay, fine. So here there is nothing, right? Like actually I think so at first time I just wrote this in a yes, in the first time I am trying this question, I just wrote this in a entirely in the int main function itself. I didn't subdivide it into functions. So in that time I used this break and remaining identifier. I just realized this. Okay, now here the print flame result. So this is going to take the current index, and if the index is 0, then it will be printing friends. If the index is 1, it is printing love, and respectively like this. Okay, fine. Now here comes the main method. In main method I will be getting the input and I will be calling each and every functions. That's it. Okay, so always in your Soliton interviews, especially this is the long programming question for the 2024 batch. Okay, so whenever you are just going with the long programming, you want to tell your mentors that this is the logic, and you want to just code it out, right? When you are coding, you want to separate them as functions. Okay, so this will be making you like error handling. Okay, it will be enhancing your error handling also, and it will be like a modular thing, and it will be reusability. So for these all cases, you want to just subdivide them as a functions. Fine. Now let me run this. Yes. So my friend and sorry, this Ritika. Fine. Yes. Now I'm going to tell you what is the Josephus theorem or Josephus algorithm. Okay, so the Josephus algorithm is basically like I can tell you like this. It is like a circle. Okay, here it is 1, 2, 3, 4, 5, and 6. Now this guy has a sword. Okay, then if I give a k value as 2, if I give a k value as 2 and the n value as 6, then n value will be 6, like 6 of them are there, and k value is what? 2, which means this first guy, this guy will be taking this guy itself as the 1. Okay, and his next guy, this is 2, so he will be killing this 2. Can you understand this? And then he will be handovering this sword to this 3. Okay, similarly this 3 also killing this 4 and handovering the sword to 5. Again this 5 also killing the 6 and handovering the sword to 1. Again this 1 will be killing this 3 now. Let me take any other color so that it will be more clear for the 1 iteration. Again he will be killing this 3 because 2 is already killed. Okay, and handovering the sword to 5. Can you understand this? Yes. Again this 5 will be killing this 1, and he don't have anyone to hand over the sword, so this 5 will be the survivor. So the Josephus theorem or Josephus problem is stating like there are n members in a circular format, and I will be giving you what is the interval to kill a person. Okay, and after killing a person, you want to just hand over the sword to the alive person, and that alive person will be just continuing with that step, similar step. Okay, so it is like a main problem that is divided into subproblem, and at last there will be only one survivor, and he is going to be the winner. So this is the same algorithm that is done in the flames also. Can you understand this? So my kind request is just practice as much as problems, because when you are practicing more and more problem, you will be encountering more and more algorithm, and whenever we are encountering in an interviews point of view, you are just going to solve them in your own algorithm. But if you already solved that question in any other algorithm, it will be more efficient. Can you understand this? That's why I'm telling you this Josephus problem. But it is not mandatory, but still you want to know this Josephus problem. Okay, fine. I'll be quickly explaining this. So already I told you that we are just going to subproblems, and at last there will be only one survivor. So basically it sounds like recursion. Okay, so whenever you are hearing this recursion, I know many of them are not well versed in this recursion, but still in this problem this recursion is quite simple. Okay, so let me explain you. First of all, let me have a function of n and k. Okay, n value and k. So I want to go with f of n minus 1 comma k. So what this f of n minus 1 comma k represent? See here, whenever I am killing a person and handovering the sword, the interval will not going to be changed. This k value is not going to be changed. But persons alive going to change, because one person is died. Can you understand this? So that's why I am just going from f of n comma k to f of n minus 1 comma k. Can you understand this? In each and every recursion call. Okay, whenever I am going for this to this, what is the relationship between them, or what is the consequence we will be encountering? I will be going to the k steps ahead. Can you understand this? I will be going to the k step ahead. For example, here k value is 2. Initially, I am starting from, let me take this color. Let me, first of all, I am starting here at this 1. Okay, I am killing this 2 so that I will be just going to this 3. So it is like k steps 1, 2. So it is k steps, k steps. Okay, if for example the k value is something like 8, then I will be going for the 8 steps. 8 steps means it is 1 plus 8. So from 1 to 2 it is 1 step. So 2, 3, 4, 5, 6, 7, 8. So totally of 8 steps. So currently I will be where? I will be at 9, right? I'll be at 9. Can you understand this? Yes, but whether 9 is greater than this n or less than this n, it is greater than this n. So whenever I told you, whenever it is a circular and when it is greater than n, then what should I do? I'll be doing a mod operation with n. That's it. So similarly here also I want to do a mod operation. So mod operation with n. That's it. So this is going to be your relationship between f of n comma k to the f of n minus 1 comma k. Okay. So this is going to be your body of the recursion. And what is going to be your base condition? So what is the base case? If the n value is equal to 1, which means I have found the last survivor. So in this case, I will be returning 0. You don't want to do anything, just return 0. That's it. Because whenever I am calling itself, I just made sure that k plus the function call. That's why I'm just returning 0. That's it. That's it. So this is going to be your overall code. It is so simple. Okay. So let me go here. So this is going to be your code. Okay. In your flames, you know that n value will be always 6. So we don't want to care about this n value. But this k value going to be changed, because in some cases, in my example, there is 10. In some other cases, it can be 11, it can be 1, or it can be 2, or maybe it can be 0. Can you understand this? So for these cases, so whenever it is 0, it is like we cannot define anything. Okay, so always in the constraint they will be giving like it will be greater than or equal to 1. So this is going to be your recursion code. So here your n value for this flames always will be equal to 6. Okay, but this k value going to be changed, because in our previous example itself it is 10, but you can encounter any values greater than or equal to 1. Okay, so here I will be taking the base condition as 1 and my return value will be 0. Otherwise I will be just taking the relationship between the current function call to the next function call. That's it. Okay, so let me run this. So it is what, 3. So if the k value is 10, then what is I'm getting? I'm getting 1. So can you understand this? What this 1 represent? It is L. Can you understand this? So this is going to be your recursion code. But what is the time complexity of this recursion code? It will be of O of n. Okay, so we are just going to optimize this, and also it is of space complexity of O of n. Let me just go here. See here. What is the time complexity? It is going to be O of n. Okay, it is accepted. But what is the space complexity? It is also going to be O of n. Why? Because it is a recursion code, which means it is also having a recursion stack. If you don't know about the recursion and the recursion stack, recursion tree, just go and revisit my recursion playlist, because there I have clearly stated what is meant by recursion and recursion tree and recursion stack. Okay, fine. Now we are going to optimize it. How we can optimize it? See here, if I stored each and every value in my mind, then when we are going again, I can just taking it, right? Whenever we are going to optimize, or else just remember, whenever we are going to optimize the recursion code, then we are just going to a dynamic programming approach. How we are just going to the dynamic programming approach? It is so simple. Let me explain this in the code itself, because it is way simpler than you thinking. So see here. So this is going to be your memorization step. Okay. Always remember, when you are converting your recursion into a in a process of dynamic programming, first step is going to be your memorization. Then it is going to be the tabulation. Then it is going to be the space optimization. Hope you understand this. So these are all the terms you want to know when you are going for the dynamic programming. But here the dynamic programming will be going to be way much simpler. Okay. So see here. First of all, I will be taking dp of n plus 1. Why I am taking dp of n plus 1? Because what are all the variable things, or what are all the variable parameters I have? This n value will be variable, but this k value will not be varying. Can you understand this? This n value going to be variable. So that's why I'm taking the n value alone. If the k value is also variable, then I will be taking a two-dimensional array, which means a matrix. But here I'm going to take a single-dimensional array. Okay, that's why it is dp of n plus 1. And then I'll be taking all the elements as -1. Just make sure you cannot initialize the value here, because it is what? Variable length. Okay. So that's why I'm taking a for loop and initializing as -1. Okay. Now here I'm going to add one line, like if the current n value is not equal to -1, then I will be returning the current in this value. That's it. Okay. And also here n plus 1. Why I'm taking n plus 1? Because here I may also have dp of n. So for n in this, I want to take the array length of n plus 1. Can you understand this? Yes. Now before I am just returning, I want to just store that value in my dp of n. Can you understand this? Fine. So this is going to be your memorization code. Let me just do a run. See here. Yes, it is giving you what? 1. Okay. Now let me just comment this out. Now next step is going to be your tabulation. So tabulation is basically a easy function. Okay. So let's see here. I'll be taking this in my paint. Okay, continue. So this is your memorization code, right? Now we are just going to convert this into a tabulation. So first of all, before converting this into a tabulation, you want to check whether what is the procedure we have done here. So here we have done a top-down approach. What is meant by top? Sorry. Yes, what is meant by top-down approach? It is like we are just taking from the n value up to the 1. So it is a top-down approach. So now we are going to do a bottom-up approach. Always do in a reverse fashion. Okay, so bottom-up approach. Okay, so from this bottom-up approach itself, you can just clearly state that we are just going from the 1 up to n, like that. Okay, so what is the first step you want to do? First step is initializing this. So dp of n plus 1. So first step is initializing this. Okay, and then this step also. Okay, now what is the next step is, I want to just go with the for loop of, see here, what is here? If n is equal to 1, then I want to return 0, right? So after initializing, after initializing up to this step, you want to do dp of 1 is equal to 0. Okay, and you want to put a for loop, and now you want to go with the index of 2. Okay, you want to go with the for loop of from 2 up to n. Okay, now just take this line and convert it. So how we are going to take this line and convert this? So dp of n is equal to k plus, instead of this you want to take dp of n minus 1 and k. Can you understand this? Just take this and write here, and take this and write here. So k will be not here, right? dp of -1, that's it, because k is not a variable factor. Can you understand this? Now mod operation with n, that's it. So this is going to be your tabulation code. At last, what you are going to return or print? I am going to return or print what? dp of n. Here also you are returning what? dp of n, right? So if you are printing or returning, you want to do a dp of n. That's it. Hope you understand this. So here it is not necessary to initialize it to -1 also. Can you understand this? You can also initialize this as 0, whatever, because the current index element is not affecting the current index element. The previous index element only affecting the current index element. Fine. Now my time complexity will be of O of n, and space complexity is also O of n, but we get rid of the array we have used. Sorry, we are get rid of the recursion stack. So recursion stack is get rid. Can I understand this? Yes. So let us see the code for that, then we can come back. So this is the code for the tabulation. So see here, code itself simple. So initially I'll be taking the n and k value and initializing the dp as n plus 1 and making the dp of 1 as 0. That's it. Then remaining thing is as usual. Hope you understand this. Now let me take this as 10. So if I run this, 1, simple, right? Now we are going to the space optimization technique. How we are going to space optimize it? So still the space is of O of n because of the given array. We are taking the auxiliary array, right? Here, dp of n plus 1. So if I get rid of this, then my space complexity will be efficient. It will be efficient of O of 1, right? So what is the procedure or what is the method I am going to do now? Let me take the code there so that it will be more clear. Let me take this code and explain you. See here, we are just using what? We are using either the previous or the current. So I want to use only 2 space. Okay. So why should I take up to n space? Can you understand this? So simply I am just taking this as current and I am taking this as previous, and then I will be swapping it like just here. This line going to be same. So n value is initialized and k value is initialized. Next thing is going to be your previous. Previous will be is equal to 0. Okay, and current will be equal to 0. Fine. Now I am going to do a for loop of 2 up to n. Inside this for loop, I am just taking my current is equal to previous plus k mod n. Sorry, mod I. Can you understand this? Yes. So here I wrongly written I, right? Sorry, n, right? Sorry. Here it will be I. Why I am writing here as I? Because in your each and every iteration, the I value will be changing. Right? In recursion also, we are just doing what? Here mod operation to n. But this n may be of 2 or 3, anything, right? So here it will be I. I mistakenly told you that it is n. Sorry, it is I. Okay. Now just see this carefully. Now I will be making my previous is equal to current. That's it. At last I will be returning my current or printing my current. So this is going to be your code for the space optimization. Can you understand this? Yes. So basically the space optimization is like, hey, we only want 2 space. Why I want to take a n space instead? Okay, instead I can take only 2 space. So now the time complexity will be of O of n and space complexity of O of 1 for this algorithm. Can you understand this? Now see these 2 lines. So basically I am not storing anything in this previous and current, right? They both will be same at the end of this operation or at the end of this iteration. So instead of taking this previous and current, I'll be taking as usual of only one thing, like I'll be taking a current. So let me strike out this and then strike out this. Instead of this previous, I'll be taking this as current. So finally my code will be something looking like this. So only of 4 lines. So let me write here. So n is equal to 6, k is equal to 10. Instead of current, let me take a position so that it will be more clear. So position is equal to 0. For from 2 up to n, I'll be going and taking the position is equal to position plus k mod I, and then at last I'll be printing or returning the position. That's it. So this is basically of 4 to 5 lines. So this is your code for the flames algorithm. Can you understand this? Instead of taking the 5 iteration and going on to the count and then taking a index, no, this is simple. This is simple. Can you understand this? So this is going to be your Josephus problem algorithm. So let us take the example coding. So see here, this is going to be a space optimization, as I mentioned in the drawing explanation itself. But if I going for the modified code, then this is going to be your modified code. Let me just uncomment this. Now just take k value. K value will be 10, right? And then what is going to be your n value? It's going to be always 6 for the flames. Okay, it is 1. Can you understand this? So basically I have told you what is the simple approach for that, and I just told you the Josephus approach as the bonus approach. Just know that it can be also solved using the Josephus approach for this just 4 lines of code. Can you understand this? So I hope you can understand the both approaches. If you don't understand any steps, or if you spot any errors in my code, just comment below. I'll be just commenting out in the comment section, or else I will be putting separate videos for those doubts also. If you really like this video, subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are appearing for the Soliton interviews. And to know about these kinds of algorithm like Josephus algorithm or any other algorithm, just go and check out my YouTube channel. And if you want to know about the recursion, you can go with the recursion playlist. And newly I'm just launching the dynamic programming approaches also. So it is way easier than you are thinking, and it is in the Zoho playlist and also in the dynamic programming playlist. So hope you understand each and every steps and each and every logics and each and every approaches. Thank you.